This question, the title says reverse list starting at index k. Now, in this question, you are given the head node of a singly linked list and a natural number k. K will always be less than or equal to the length of the list. K is less than or equals to the number of items, the number of nodes which are there in the singly linked list. What we need to do is we need to write a function, reverse at position, which takes the head of the linked list and the position from where we have to reverse. So it takes those two parameters and it reverses the linked list starting from the index k to the end of the list. And indexing, by the way, starts at 0. Hi, everyone. My name is Ravi. I have more than a decade of experience in the tech industry. I have worked for a bunch of companies, including few MAANG companies. I am currently working, I would say, in the senior engineering space in one of the MAANG companies. And I have dealt with different profiles, including data engineering, including backend engineering, and a lot of interesting stuff. And I also like to casually interact with the learners, with students, by sharing my knowledge over all these years to help them understand more about different profiles, different interview processes, and how to perform better. So that's about me. And let's get started to go through one of the questions that has been asked at Google and, in fact, top tech companies. This is a sample class, how a simple sample node class, linked list node class looks like. This is the representation in the code. And we have certain things that we need to note that after the reverse operations, you must update the new head node using the update head node function, especially in the case where n equals to 1, and the tails next node will be none. So these are certain, I would say, instructions which are given around the question. Here is a sample input that is given for our better understanding. You can see that this is the linked list which is given 1, 2, 3, 4, 5, 6. The position where we have to reverse it from, this position is given as 2. So indexing starts at 0, 0, 1, 2. That means we have to reverse from this point onwards. And as you can see, the output is as expected. So 1, 2, 3 remains as it is till index 2. Then after that, everything is in a reverse order. As you can see, 6, 5, and 4. So I think the question is pretty much clear to me. Let's start approaching this question. So at the very outset, when I think about the question, first of all, I think this is a really good question, both from for, let's say, even if we talk about a data science position or even a data engineer position. I think it's a really good question to test their coding preparation, their coding knowledge. Not too complex enough, but still good enough to get their understandings around how good they are with respect to coding or problem solving, which, by the way, problem solving is one of the rounds which is asked in interviews for several positions. So this question, I think, is a really good one. Now, in a very naive thought process, if I think about this question, I would say that in a linked list, usually what happens, let me go to this board here. Okay. So what happens in a linked list is that we have nodes. So let's say something like node 1, and then there will be a pointer like node 2, and then we'll pointer to the next node, node 3, and likewise, the last node will have pointing to null, like nothing. That will be the last node. Now, in this way, if we are expected to kind of reach a certain index and then reverse the data from there onwards, the naive thought process inside me tells me that we first can reach up till that position. So for example, let's say I'll just include few more here. Node 4 points to, I would say, node 5, and that is the last node. So as per the naive approach, let's say we have to reverse from this point onwards. Okay. I'm thinking that somehow we reach up until this node, up until this position. And from there, what we will do is that we can store all the nodes like node 3, node 4, node 5. We can store all these nodes in an array, in a list kind of a thing. In the Python terminology, I will store all these nodes in a list. And then maybe I can reconnect the reversed portion in the list. I can play around with the data, by the way. I can simply do a reversal of those stored nodes. And then I can reconnect the reversed portion back to the original list. For example, like what I'm talking is in my list, like node 3, node 4, and node 5 will be stored, something like this. I can simply reverse them so that it will become like node 5, node 4, and node 3. And now what I will do is I will just connect this node 2's pointer. I'll start connecting them to this node 5, this node 4, and this node 3. So that will be a very naive way of doing this. This is definitely a workable solution. And the only problem which I see with this solution is that we are needing an extra space for storing these nodes, for storing these things inside a list. That accounts for an extra space. So while I would say that this naive approach, as I said, it's a completely workable solution. And many a times from my experience, what I have seen is in a data engineering and a data science kind of a positions, the workable solution works very much actually. The interviewer should be able to accept that. But now, as let's say, how will you set yourself apart as a candidate is what I'm thinking. If I'm a candidate, I would be thinking that how can I perform still better? How can I go one step beyond the working solution? So I would think of an optimization here. That will be the thought process if I have to differentiate myself. Now, the optimization which is clear here is how can I get rid of this extra space and still solve the solution, still arrive at the workable solution. Okay. Now, for the optimization, getting rid of that extra space is my goal. And that makes me think that can I do something that I can reverse or achieve this reversal in place, as in let the nodes be there in the linked list itself, and I just reverse it from there itself. I don't need any extra space. That is what I need to do. That should be my goal if I have to do the optimization here. So while I would be thinking whatever I'm thinking in an actual interview, the best way to go about this is to actually keep your thoughts communicating with the interviewer. The way just I am doing all of this, I think that's the exact way I will replicate it in an actual interview, where I would be thinking out loud, calling out my approach, whatever is going on in my mind, calling out the drawbacks, the loopholes in my approach, talking about how I can close those loopholes, how I can optimize the approach. So this is the exact way I would say, or in fact, the best way to get the conversation going in an interview where you're thinking out loud. That's the mantra here. Okay. So let me build on that optimized approach, which I just now discussed. So for the in-place reversal, the approach which right now I'm thinking about is that the traversal to the desired position, that part still remains the same, that I still need to reach that position. In the question, the position is given as one of the parameters. So that's known to us that from which position onwards we have to reverse. I will still use that factor to iterate, to reach up until that particular node from where the reversal has to start. So that part I will still do it. Okay. And to achieve that, again, translating or thinking from a coding perspective, I'm thinking of keeping some trackers, some pointers here, which will help me keep track of the current node where I'm at, the next node. The next node will obviously be known to me because of the next pointer. And for this scenario, since a reversal is involved, I somehow see that I would need to keep track of the previous node also. For example, if I have to reverse from this point onwards, I would need to keep a track what was the previous node for this node. So I do see a potential that I would need to use it. I'm not yet sure about it. Let me come to the code and then we'll finalize if we need that. Okay. Now, let's say once we have reached the desired position, now our actual logic, the actual action starts. Okay. Now, what I will do after reaching that is I need to reverse the pointers of the node. When I say reverse the pointers of the node, essentially, if I just, the picture that I had drawn earlier is that the reversal would look something like node 5 would point to node 4 and node 4 would point to node 3. And now the pointer for this node 2, I just need to connect this to this node 5 thing. And that's it. My original list has been reversed or would have been reversed from this point onwards, wherever the desired position was. Now, the thing is that we need to reverse the pointers of the node. So if somehow what I can do is this in the original list, this node 5 is currently pointing to a null, as I can see clearly. This pointer, I need to make it point to this node 4, which is the previous node, by the way. So that is where, that is where my thought process was coming, that we would need something like a previous here to keep track of which is the previous node so that I can make the pointer of my current node point to that previous node. That is the way I am thinking of achieving the reversal of pointers, I would say. So talking on that same time, same theme, previous, current, and next. I think these 3 pointers will definitely be needed for this particular solution. And previous will obviously point to the node which is, before the current position. Current is pointing to the current node and next is next to the current one, I would say. Now, and once we have done this pointer reversal here, as I said, the last part will be to just connect this point from where we left to this, I would say, new node. That would mostly achieve, I would say, what we are looking at. Now, I'm just thinking of there might be certain edge cases also. And at this point of time, I would actually confirm my understanding with the interviewer. I would casually, or I would say very, very thoroughly check with the interviewer that do they have any questions, or are we good with this solution, or does the approach make sense to them, and if we can move to the coding part or not. I would acknowledge that there might be certain edge cases for sure, but rather than thinking about them right now, I think first I will complete the actual core solution, and then we can move to the coding part. That is something which I will recommend, and that is what I will get a go ahead from the interview. That's my recommendation. So at this point of time, I think I'll move ahead with the coding part. So let me see what we have as part of this. Okay, so we have all the things in place as I see, like the node class is already defined. I think this is already defined. I don't need to take care of this. I just need to complete this particular function as it is given. Reverse at position, the head of the linked list is given, and the position from where we have to reverse, that's given. So I think I just need to complete this. All right, so let's get going. Let me think about this. What I can do is I have the head. I don't see any particular constraint as such given in the question that whether we will always have the linked list or not. That means, like, if let's say the linked list itself is null, I think I can check for that condition also. Like, if the head itself is not present, that is, the linked list is null. So I would like to eliminate that scenario. And in that case, I would simply return none, because there is nothing to reverse actually in that scenario. So that is something what we can do. So that's one edge case at least I have taken care of. There might be further edge cases. I'll come back to that when I'm done with the core solution. Now what I will think is I will think about traversing to the position, to the given position. That will be my thought process. How can I do that? I think I have the position, which is an integer. So I need to reach up until that integer. In that way, I think having a variable called count will make sense here, because this will help us keep track that until we have reached that particular position. So while count, I would say while count is less than position, I think that will be the condition I'll compare. While this is the case, I would say, okay, so I would need to keep a track where I'm at currently, what is the previous node, what is the next node. Next node anyways, I will get by the next pointer. So I don't think that's too much of an issue. So I would need to define few more variables. I see the need for them. I can have a previous, which I can initialize to none, because when we are just beginning with the linked list, current I can keep, or I would say current, I will make it point to the head. I will start from there. Previous will be the previous one. So at that point of time, it will be a none. That makes sense. Cool. So previous and current, and while my count is less than the position, the currently count is 0, indexing starts from 0. That's the hint which is given in the question. I would say that my current can be current dot next. I would move my current pointer, and I would also need to keep track of the previous. So if I move my current pointer, and if I do the previous equals current after that, I think that will, mess up things. So I first need to record the previous when current is not yet moved. So this activity will be done first. I first need to capture where the current is at currently, and then I will move my current pointer. I think that's the right way to do it. And once I have made that movement, I think I'll increment my count. I'll increment my count by 1. Yep. I think that's the right way to do. And this also brings me to a point that, if what if the position is the last one? Position can be anything. There is no constraint as such given. So in that case, if we go on incrementing current, we also need to make sure that we are not pointing to a null. That means we do not reach the last node. And then in that case, current will be current dot next, which will be null. If we still try to do it, it will result in a null pointer. So just from a security perspective, like I would say not a security perspective, just from a cautious perspective, I would also check that current is not none. I would also check that, and the count is less than position. So I think this way it will be good to do. And this would make sure that I have traversed to that given position. So I think this should be good. Yeah. After this, I would say that once I have reached that position, now our reversal should begin. So I would say that again, the reversal I would do with a while loop. I'm not yet sure that what condition I will put in the while loop. I'll come back to that later. Just a moment. Yeah. But for the reversal, what I'm thinking is I need to make, if I go back to my notes here, what I can do is I can take in this scenario, when we reach this position. So position is 2, 0, 1. So just taking this one, sorry. So position is 2. So 0, 1, 2, 0, 1, 2. So that means these are the nodes. So that means when we come out of this while loop in this particular example, our current will be at 4, our previous will be at 3. That will be the scenario. Okay. So what I'm going to do with that, information, what I will do is I will get a hold of the next node for sure. So I will get a hold of the next node that will be with current dot next. So that means this node 5. So I would get a hold of that. That's one thing. And in fact, just to differentiate it from this dot next, I would just name it next node. That's a good programming practice. Always good to, improvise wherever you see the room for improvement. So I would use the next node here. Okay. Then what I can do is I need to reverse it, right? So how do I reverse it is this 4 has come at the last. That means the force next, currently it's pointing to 5, but in a reversal mode, the force next will be pointing to a none or a null. That is the expectation. So I would have a separate previous here. I would have a separate previous pointer here. Maybe something like a previous reverse, because this is the previous pointer which is used for the reversal, reverser section, the nodes from where we have to reverse. So I would use that here. Okay. And why I would need it is because I would need my current pointer, which is this 4, the current dot next. I would need this to point to null. As you see, 4 in a reversal mode is the next of 4 is pointing to null. So I would achieve by this. Okay, I would assign the previous reverse to this current dot next. I would assign that. And then what I will do, I would move this previous reverse. I would move my previous reverse to now point to the current, actually. Okay, great. Now I have done that. And I would move my current to point to the next node. Now, why I'm doing like this? Because precisely what I will do is I am making this pointer, I'm breaking this, I would say pointer, and making it point to a null. And then I'm making this one, the next pointer. Right now, this next nodes, next is pointing to 6, but I need to break this pointer and make it point to the previous one. So that is what I'm trying to do, that once I have this previous recorded, so now this previous is pointing to this 4. And if let's say my current moves here, now this current dot next will point to the previous. That means this one. And that is what is the intention. So you see, this is what this code is going to achieve. And I'm sure it might be confusing, but let me just complete. I think I know what I'm doing. Let me just complete this section and it will make a whole lot sense once I am done with that. So the thing to be done is I have to move my current to the next node here. Okay, perfect. I have already captured the next node. So yes, I think this is all which is needed to reverse it. So what will happen here? And all of this I will do while current is not none. The same logic which I had implemented here for the while loop. I think I'll keep on doing till that. So what will happen here? My current is here. Okay, to begin with. I am capturing the next node, which is this now. Okay. I am making the current dot next, which is currently pointing to this point to null, which I have assigned this previous reverse. I'm doing that. Now this previous reverse, which earlier is pointing to null, now it is now pointing to this current by this one. And now this current moves to the next node, which I have already captured here. So now current is here, previous reverse is here. Now I will repeat this. Current dot next. Current dot next is this. This becomes my next node, by the way. And I would say current dot next now should point to previous reverse. That means this previous reverse, current dot next, which is pointing to this, now should point to this 4, which essentially is my end goal. And this previous reverse should now, which is now currently pointing to this, should now come to this 5. And current, which is currently at 5, should now move to this next 6. So you see how our pointers are getting reversed. 4, which next was pointing to this 5, now it is pointing to null. 5 next was pointing to 6, now it is pointing to 4. So we are slowly achieving that, and that was the intention, that what I was trying to do. So this would help us reverse it. This is the reversal part completed here, I would say. So in fact, let me just put it into comment that reverse the linked list from the position. That's what this code will do. And once I have done that, I would say now the only part remaining is to connect it, connect the reversed part, actually connect the reversed part to original list, I would say. Yeah, that's the thing. So how do we do that? So remember, in the original list, we had this previous. Okay, we had this previous. That is why I took a separate previous reverse pointer for this reversing thing, the reversing section of the linked list, because I still don't need to change this previous, because this will be used to connect this original list to the reversed part. So the previous, when I reach till this position, is pointing to this. So what I can do is I can actually make the previous dot next should point to what? Should point to the head of the, I would say, should point to the head of the reversed linked list. And the head of the reversed linked list would actually be pointing to this once, because the condition I have used is when current is not none. So current, once it has reached here, once the reversal has happened, like 6 is now pointing to 5, then current will be current equals next node, which will be null. And that means previous reverse, like current will point to null, but previous reverse will point to this. So that means this becomes the head of our reverse linked list, is what I'm thinking. And now what I can do, previous dot next, that means this 3 dot next should now point to this 6. So this should point to this previous reverse. I think this is the way to connect, but I'm just thinking that what if, okay, this is an assumption that the position from where we have to reverse is somewhere in the middle. What if this position is at the beginning? What if, like, instead of reversing from some position, what we have to reverse, from the beginning of the linked list? That is also a possibility. I do not see anything specific as such mentioned. And there will be clarifying questions that will need to be asked with the interviewer. I think I did not talk about that specifically at the beginning, but for sure, I think there should be clarifying questions. Clarifying questions should be asked to the interviewer. So that is something that should be done at the beginning, I would say. But still, nevertheless, you should be in a continuous discussion mode with the interviewer. So you can ask that, will the position will always be in the middle somewhere, or maybe it can be in the beginning, at the end, so anywhere. So you can ask these clarifying questions. Other questions can be that, although the values do not make much meaning here, like it can be negative, positive, anything, but that does not hold any importance. But apart from that, yes, can the linked list be null? Do I need to take care of that? So that is where this edge condition comes into picture. So you can clarify all of these things. But what if the reversal has to be done from the beginning? So I think if that's the case, first of all, how will I identify it? I think the way to identify is that my previous will remain none. If my reversal has to be done from the beginning, that means I will never enter this thing actually, because the position will be at the 0th index only, and my previous will remain none in that case. So I think to establish if the reversal has to be done from the beginning or the middle, I will check this. If previous is not none, then I will apply this, okay? Else, if the previous is none, okay? Else, if the previous is none, what I will do is my previous reversal, this should be assigned as the new head of the linked list, this original head actually. I think that way we can complete the reversal part. And at the end of all of this, essentially, I think we can return the head. That should do it. I think overall this looks good to me. Checking. I'm just checking and thinking that might be there are some more conditions. Just in my mind, I'm trying to do some dry run, and that is again suggested that rather than running the code directly, it might be good. It might be a good idea that you can do some dry run and just establish that roughly if your code looks overall fine or not. One thing which I'm thinking as one condition, which may be, I thought about what if the reversal is from the beginning of the linked list. Do I need to think about any particular scenario? What if the position from where the reversal has to happen, if that is at the end, what will happen? So if the reversal is towards the end, I think towards the end, then in that case, no reversal is needed, because, I mean, what it means that if, let's say, the position is this, the end position, the end index, in that case, what will you reverse? Like, there is nothing to reverse from this point onwards, actually, because there is no item in the list. In that case, there is no reversal needed. So I think I will also check that if current is none, because if current is none, in that case, we have reached the end while trying to reach that particular position from where reversal has to happen. And that signifies that the position from where the reversal had to happen is actually at the end. In that case, I think there's no reversal needed, and I can simply return the head of the linked list. So I think overall this looks good to me. I don't see any more conditions that I need to cover here. And at this point, I think I'll go ahead and try to run my code and see what results do I get. Okay. It says test cases passed. Okay, it passed one. No, none failed. Great. The expected output was 1, 2, 3, 4, 5, 6. It's 1, 2, 3, 4, 5, 6. Okay. Seems something is wrong here. Let me just check. Okay. Argument number two. Oh, argument number one, argument number two. Oh, okay, okay, okay. Test input. All right, all right. Okay, now I get it. I get it. I'll just explain what's happening here actually. It's slightly confusing given this was the example it was given. So it changed the examples at the time of test. The input it has given. You see, argument number one, the input it has given, it has already given the reversed one, this one. So this is the input which is given for the test 1, 2, 3, 6, 5, 4. The argument which is given is from the third index onwards. So 0, 1, 2. So from this index onwards, it should reverse. That means the expected output should be 1, 2, 3. Reversal of this will be 4, 5, 6. That's the expected. And my code output is the same 1, 2, 3, 4, 5, 6. So it pretty much passes. And if I go ahead and submit the solution, it accepts, it passes all the test cases, and that should be it. I think that should be it overall. If I see the improvement which I have done, just to summarize this, I think the time complexity that it takes, it is definitely O of n, which I am thinking, and talking about these things are again a good way to differentiate yourself from the rest of the crowd to stand out in the interview, because talking about an optimized code, the efficiency it presents, and getting into the details of those efficiencies are definitely going to impress the interviewer. So I would summarize, the time complexity. This is definitely O of n. We are just iterating once over all the nodes, and we are not taking any extra space. We were taking one in the previous naive solution which I had presented, if you remember this one. Yeah, I think I erased that. But we were using an extra array. But in this case, I think I'm pretty much reversing using the pointers, no extra space. So the space is pretty much like O of 1, you can say, like there's no space at all needed. So I think this is a very efficient solution for this question. And this should be a good to go in an actual interview. And I did present a lot of scenarios, a lot of discussions that you need to be carrying out with the interviewer. Obviously, if this was an actual interview or an actual mock session, things would have been much more transparent and much more, good to follow. But definitely take the pointers at certain positions, which I told you. That would be good to follow in an actual interview also, and you can use that as a template overall. So that's all from my side for this question. I think it was a very good exercise, and I hope you learned something out of this. All the best, and I will probably see you in some other video.